Which of the following represents the approximate area under the curve of f of x as f of x is equal to 1 plus x cubed on the closed interval from 2 to 5 using midpoints and 3 equal subintervals? So our first step will be to calculate delta x. So knowing that we have our interval it's a closed interval from 2 to 5. 2 minus 5 is 3, and 3 divided by 3 is 1. That's how we get delta x is equal to 1. The next thing we want to do is actually look at the subintervals. So our first subinterval will go from 2 to 3. Our second subinterval will go from 3 to 4. And our third subinterval will go from 4 to 5. Now also keep in mind we're using midpoints. So the midpoint of the rectangle that is coming up from here will be at 2.5. The curve is going to pass through the top of the rectangle at that point. The second subinterval is 3.5. That's the midpoint. And so that means the curve is going to pass the midpoint at the top of that rectangle. And then the third subinterval midpoint is 4.5. So when it comes to setting up our summation, what I want to happen is I want the index I to go from 1, 2 to 3. And at the same time, C sub I is going to be 2.5, 3.5, and 4.5. So I want, when I is 1, I want 2.5. When I is 2, I want 3.5. And when I is 3, I want 4.5. And it's obvious that you're adding 1.5 each time. So C sub I will equal to my I value plus 1.5. To find the height of the rectangles, we're going to find f of C sub I, and remember f of x is equal to 1 plus x cubed. So it's going to be 1 plus, and instead of x, I use my value of C sub I, 1 plus, I plus 1.5 cubed. Now the area is going to be delta x times f of C sub I. From up here, we know delta x is equal to 1, and we know that f of C sub I is equal to 1 plus I plus 1.5 cubed. Now, since 1 times anything is itself, what we have is the summation of these three rectangles from 1 to 3 of our f of C sub 1, so our correct answer is C.